What is an integrated circuit and how does it relate to 50s transistors? Imagine a tiny chip that can hold hundreds or even thousands of tiny electronic parts all working together. That's what an integrated circuit is. It is a small piece of silicon that contains many transistors, resistors, and capacitors all built into one compact unit. This invention changed everything because it made electronic devices much smaller, faster, and more reliable than ever before. Back in the 1950s, the transistor was a huge step forward. It replaced bulky vacuum tubes in radios, televisions, and early computers. Transistors were smaller, used less power, and lasted longer. But each transistor was a separate component that had to be wired into circuits. As electronics grew more complex, connecting all those individual transistors became difficult, expensive, and prone to failure. This is where the integrated circuit comes in. Invented at the end of the 1950s by engineers like Jack Kilby and Robert Noyce, it was a way to put many transistors and other parts onto one tiny chip. Kilby's first working integrated circuit in 1950, it used germanium and combined a transistor, resistors, and a capacitor on one piece of material. Noyce improved the design by switching to silicon and adding a process called planar fabrication, which allowed metal connections to be layered on top of the chip. This made mass production easier and more affordable. The invention of the integrated circuit built directly on the transistor's success. It took the idea of smaller, more efficient electronic parts and combined them into a single, integrated system. This allowed engineers to create more complex circuits without the mess of wires and separate components. It also paved the way for the rapid growth of computers, radios, and televisions in the 1960s and beyond. In the 1950s, the transistor was already transforming electronics by making devices smaller and more reliable. The integrated circuit took that progress further by shrinking entire circuits onto one tiny chip. This leap made possible the miniaturization of electronics that defines the modern world. It was a time of great optimism and innovation, where engineers pushed the limits of what tiny transistors could do. The move from individual transistors to integrated circuits marked a major step toward the digital age we live in today.